Welcome pre-cal students to class today on this Thursday the 15th. Hope you guys are doing well. Hope you're ready to review some math today. Last video of the school year, so congratulations. There was probably some points in the year when y'all thought you would never make it, and you have finally made it. So we will have a test tomorrow. Please keep that in mind. I will email that to you. Don't forget you owe me some tests if you're going to get those turned in. And on your exams, remember you can set a time up to come over here next week and take it. That's fine. Or you can take it at your house and then get your questions ready and then come on over with your questions. Okay? So today we're going to wrap up this huge section on equations. Now remember, your test will have basically two sections: a graphing section and an equation section. Although, as you can see, there will be some inequalities, and actually we covered some inequalities yesterday too. So but that's basically what you're looking at. So what we're going to look at today is 3, 6, 7, 8, 9, 10, 12, 14 problems. I believe I counted quickly, but 14 problems. And again, the key to understanding how to solve these on the test is going to be your ability to recognize the problems and then know what to do. Okay, so let's start off with this problem here. This is called a rational equation, and this is because we have fractions with variables in the denominator. And what I have taught you guys to do is to multiply the entire equation by whatever your common denominator would be. So in this case, your common denominator, as you guys should know by now, would be 8x plus 1 and 2x plus 5, okay? Put that all over 1, and we're going to multiply the entire equation by that. Well, we're going to take this fraction here times this fraction here, and if we do that accurately, 8x plus 1 will cancel with 8x plus 1, and we'll be left with 2x plus 5 times 3. Well, that's going to be 6x plus 15. Now let's take this fraction times this fraction here. If we do that correctly, 2x plus 5 will cancel with 2x plus 5, leaving us with 8x plus 1 times 8. Well, that's going to be 64x plus 8. And then, of course, if you take this whole group here times 1, you're just going to get itself, which would be, and really I'm going to go ahead and just multiply it out. You'll get this right here. You'll get 16x squared, positive 2, positive 40, so positive 42x, and then plus 5. Now, as soon as we did that step 1, we were able to eliminate all of our fractions. And now we should notice we have a quadratic equation. So I've got a 6x and a 64x. That's really 70x. I've got 15 and 8. That's really 23. Well, I'm going to bring these guys over and change their sign. I'm going to bring this 70 over and make it a negative 70. I'm going to bring this 23 over and make it a negative 23. And I'm going to be left with 0 equals 16 x squared. Now let's see, it should be negative 28x minus 18. Okay, so I did all of that work and I've simplified the equation all the way down to this right here. And so now anytime you have a quadratic equation, we know this, you want to try to factor first. Well, I'm always going to pull out what's common. I mean, that makes it a lot easier. I know 2 would go into both of these, so I'm going to pull out a 2, and that's going to leave me with 8x squared minus 14x minus 9, okay? Now, it's probably not a huge help, but it's a little bit of a help. Let's see. If I tried to factor this, 8 times negative 9 is negative 72. Now, I'm trying to think of two numbers that when multiplied together would give me negative 72, and it might not be possible, but I'm thinking here. Let's see, 7 times, let's see, 6 times 12 would be 72, 8 times 9 would be 72. Let's see here. I don't think it's going to be possible. Okay, I paused the video to do a little research there, and it is possible, after a little bit of division and multiplication, if you multiply these two numbers, you'll get a negative 72. If you combine them, you'll get a negative 14. So with that in mind, I'm going to write 8x squared minus 18x plus 4x minus 9, and I'm going to pull out what's common here in my first two terms. That would be a 2, and I'd be left with 9. Actually, something bigger maybe. Let's see. No, that's right. Pull out a 2, and I'm left with 4x squared. Pull out a 2x. Sorry about that. We're going to pull out a 2x. Mr. Earhart's having a rough day today. Pull out a 2x. And we're left with 4x minus 9. And then nothing common here, so I'm going to pull out a 1. And I'm left with 4x minus 9, like I should be. So we bring down our 2 on the outside. We write our matching parentheses once. And then, of course, we're left over with 2x plus 1. Now, this group here has no x with it, so I'm not really worried about that group. This group here, the solution that would satisfy this parentheses, if you set it equal to 0, would be a positive 9/4. And if you set this group equal to 0, the number that would satisfy the this equation, this parentheses here, would be a negative 1/2. Now, I always hate it when I make these mistakes, but I make a lot of them in my life, that's for sure. But I wish I had not erased that problem, because I'm really, let's see, positive 9/4 and a negative 1/2. I'm going to tell you why. I'm going to go super fast here and just kind of talk to you guys. And I apologize. I shouldn't have pulled that problem away and gotten rid of it. I'm going to tell you why. Remember, when you have a rational equation, guys, you have to check your answers. Okay, and I'm sorry that I got rid of it, but there it is. I got to get that problem back up there. Okay, now if I remember correctly, the answer, hopefully I remember correctly, was a negative 9/4, I believe, or was it a positive 9/4? Okay, it was a positive 9/4 and a negative 1/2. Now, you've got to check those two answers. That's why I had to hit that backup button over and over, Matthew and Caleb. You have to, on a rational expression, a rational equation, you have to check your answers, because if one of these answers gives you a 0 in either one of these denominators, then you can't use that answer. Now, 9/4 here does not give you a 0, and 9/4 here does not give you a 0, and 1/2 here does not give you 0, nor does it give you a 0 here. So we're fine. Both of those answers work. But I wanted to remind you, always check your answer in the original equation. So we eliminated our fractions, and then we solved the equation from there. Okay, and that is how you solve rational equations. Now, these are called square root equations, and you know that because the way that we know that is you have a variable under a square root. Now, normally what you want to do is get one square root all by itself. Now, in this problem, notice we have two square roots. So students, it really doesn't matter which radical you get by itself. For me, I'm just going to leave the x minus 1 over here on the left side, and see this negative radical right here. I'm going to bring it to the other side and make it a positive radical. Now, it gets a little messy, but stay with me and watch. The reason you want to get one radical by itself, guys, is because you want to square this whole side. Because when you square a square root, you get rid of the radical. But hold it, you can't square one side without squaring the other side. And this is where it's going to get really ugly in a second, okay? All right, so we square a square root, and we're left with the radicand, which is x minus 1. Now over here, we're going to have 1 plus square root of x minus 4 times 1 plus square root of x minus 4. And I wrote these parentheses twice because of this 2 right here. Now, here we go. This is going to get a little interesting, okay? 1 times 1. 1 times 1 would give you 1, and 1 times the square root of x plus 4 would be square root of x plus 4, and actually be x minus 4. There we go. And then you take this right here, square root of x minus 4 times 1, and that's going to give you the square root of x minus 4. And now watch carefully. Whenever you take a square root of x minus 4 times the square root of x minus 4, I took the 1 times the 1 times this, and now I'm taking This radical here times 1, and this radical times this radical. Now, a square root of x minus 4 times the square root of x minus 4 would just be x minus 4. And when you have a x minus 4 plus an x minus 4, you really have 1 plus 2 square root of x minus 4 plus x minus 4. Do you see how I did that? I combined this radical with this radical here. Now, back this up and watch it again if you need to, but here's what's so important with everything I've done here. Now, notice I got rid of this radical here, and after I did all my simplification over here, I have a radical left. So now I want to get this radical by itself, okay? So I'm going to grab this and not make the same mistake I made the last time. I'm going to drag this up here out of the way. We'll come back to it later. And now let's continue on, okay? Now we've got to get rid of this radical or this square root that is right here, this square root. So let's get us some space here, kind of like soccer. Let's create some space, and here we go. Well, I'm going to bring this positive 1 over and make it a negative 1. I'm going to bring this positive x over and make it a negative x. I'm going to bring this negative 4 over and make it a positive 4. So now I'm left with 2 square root of x minus 4, and your x's cancel here, and negative 1 is negative 2 plus 4 is 2. Now, my radical is almost by itself, not quite. Now I'm going to divide by 2, so that these cancel, and I'm left with 1. 1 equals the square root of x minus 4. And look at that. I got the radical all by itself, and now what do? Square it, but if I square one side, I've got to square the other side. 1 times 1 is 1, and when I square a square root, I'm left with x minus 4. Now bring the 4 over and make it a positive 4, and 5 equals x. Now, you do have to check your answer in these types of equations, because anytime you square an equation like that, you might create extra answers called extraneous solutions. So let's real quick put 5 in and see what happens. 5 minus 1 is 4, and the square root of 4 is 2. And bring down your minus sign. 5 minus 4 is 1, and the square root of 1 is 1, equals 1. 2 minus 1 is 1, 1 equals 1. So 5 does work, okay? All right, let's move on to the next problem. Let's grab this problem here and drag it out of the way, and let's continue on to this problem here. All right, let's take a look now at an equation that's called an absolute value equation. And you can see why it has an absolute value in it. Now, the first thing you want to do is isolate the absolute value. You want to get this all by itself. That means you've got to get rid of this 3, and you've got to get rid of this 2. So here we go. This shouldn't be too difficult. Always get rid of your multiplying number last, okay? So let's take this positive 3, and let's bring it over here and make it a negative 3. So now I'm left with 2, absolute value of x minus 4, equals, and 9 minus 3 is 6. Now to get rid of this 2, let's divide both sides by 2. Your 2's cancel, and you're left with the absolute value of x minus 4 equals 3. Now, after you have isolated the absolute value, you then want to write 2 equations always. So let's go over this again. Step 1, isolate the absolute value. Step 2, write 2 equations. So the first equation you're going to write is x minus 4 equals 3. You write it just like it is without the absolute value symbols. Then you don't change anything. You write it again, except you change the number on the right side, this constant term by itself, and you change that to a negative 3. Okay? Now let's go ahead and solve each equation, and you'll get the correct answer. Bring your negative 4 over and make it a positive 4. X equals 7. Bring your negative 4 over and make it a positive 4. X equals 1. Okay? And we do not need to check these. These will work. And so let's quickly review. Isolate the absolute value. After you've done that, it might take 1 or 2 steps. After you've done that, write 2 equations and then solve. Okay? Not too difficult. Those are called absolute value equations. Now let's go ahead and throw at you. While we're dealing with absolute value equations, why don't we go ahead and hit absolute value inequalities, okay? Now notice there's two different types, okay? There's the one type that has the absolute value and then a greater than, and then there's the type that has the absolute value and the less than, okay? So we got to talk about these two because they are two different problems and they are done differently, okay? And I probably will give you both of these on your exam, all right? So let's take some really good notes on these. First of all, do remember, before we get started, you always want to isolate the absolute value first. Please, please don't forget that. Isolate the absolute value. Okay, now if you look at this number here, it's already isolated. If you'll look at this problem here, number 23, it's already isolated. But if it wasn't, do that first. Now, once you've isolated the absolute value, here's what you need to know. If you have an absolute value is greater than a number, you will get out a disjunction. If you have an absolute value less than a number, you will get out a conjunction. Now remember, a disjunction is when the graph looks something like this. One goes to the right and one goes to the left. A conjunction is when you have your 2 points here and one goes this way and one goes this way, and you've got this area right in here. Okay, so please understand that. All right, so let's go ahead and solve this first problem. Okay, well, I guess we'll start with number 24. Now, first of all, isolate the absolute value, and we've already done that. Okay, so next we realize that we have an absolute value greater than a number. So we know when we're all done, our answer is going to be a disjunction. Now, here's what you do. Please listen carefully, Caleb and Matthew. The first thing you do is you write the inequality just like it is, only you drop the absolute value symbols, okay? Now the next thing you do, excuse me, is since we know it's going to be a disjunction, we put the word or, okay? And then we write the equation like it is, only we turn the arrow, so now it's facing this way, and we change the sign of this number. And now you just solve this side, then bring down the word or, and then solve this side, and you're done. So bring the 4 over and make it a -4, and we get x is greater than -2. Then bring your or down, and then bring your 4 over and make it a -4, and you get x is less than -6. And that's your answer. It was so important to know at the beginning, when you have an absolute value greater than a number, you will get out a disjunction, okay? Now, trying to think what I was going to say here. Oh, if you were to graph this, you would have a point at -2. It'd be a closed point. And you would have a point at -6. It'd be a closed point. X is greater than -2 going this way. X is less than -6 going that way. And there we go. Okay? There we go. Now let's go ahead and take a look at the next problem. The next problem is the one in which we have an absolute value less than a number right here. Now first of all, you isolate the absolute value, and we've already done that. So next we realize we have a less than a number, so we know our answer is going to be a conjunction. Okay, so here's what you do. You do it a little differently. You write the equation just like it is, only you drop the absolute value symbols. Okay? Then you come over here and you draw your arrow like this, okay, pointing the same way, and then you put a -5 over here. Let's go over that again. I'm teaching it a little differently now than I did during the school year. I think you'll find this a little easier, okay? So you write the inequality just like it is, only without these absolute value symbols, okay? Then whatever number you have here, you change the sign and put it right here, and then you bring this arrow down and put it like that, face the same direction. And now you have a conjunction. Remember how you do this? You want to get x all by itself in the middle, so you bring the 1 this way and put a +1, and bring the 1 this way and put a +1. So I'm left with -4 less than 6x less than 6. And now because I want to get x by itself, I divide everything by 6. Okay, so I'm left with -2/3 here. In the middle, my 6's cancel, and I'm left with x. And then on the right, I'm left with 1. So there's your answer. x is greater than negative 2/3 and less than 1. If you were to graph that, you would have negative 2/3 here, it'd be an open point. You would have positive 1 over here, it'd be an open point. X is greater than negative 2/3, so we're going this way. X is less than 1, so we're going this way. So there's your graph right there in between those two numbers. Okay, so that's how you graph. We've looked at 3 problems, okay? And I think I just did something here I didn't want to do. Hold on here. I'm not sure what I did. Let's see here. Okay, let's try this again. All right, so we looked at 3 absolute value problems. An absolute value equation in which you isolate the absolute value, then write 2 equations and solve both equations. And then we looked at absolute value inequalities. One in which you have an absolute value is greater than a number, and that's always going to give you a disjunction. And then an absolute value less than a number, that will always give you a conjunction. And then of course you solve them using the steps that I gave you, okay? All right, now let's just look at a regular good old-fashioned linear inequality. These are easy. Boy, you like these. I mean, this is simple. A linear inequality. We're going to solve for x. So we bring the 6x over, make it a negative 6x. Bring the negative 7 over, make it a positive 7. 8x minus 6x is 2x. Less than, bring down your less than symbol. And 3 plus 7 is 10. And now divide both sides by 2. And x is not equal, sorry about that. X is less than 5. There we go. If you were to graph that, here's 0, here's 5, it'd be an open point, and you would go like this. X is less than 5. Now let's take a look at a good old-fashioned conjunction, and we just did one of those a second ago, so I think you'll find it pretty simple. Here we go. A good old conjunction. Let's go ahead and solve this. Let's get x all by itself. And so we're going to bring the 1 over and make it a negative 1. Bring the 1 over and make it a negative 1. And we're left with negative 4, and then 3x in the middle, and then 4 on the right side. Okay? And now divide everything by 3. So you're left with negative 4/3. And then 3x divided by 3 is x, excuse me. And then 4 divided by 3 is 4/3. And if you were to graph that, of course, here's 0. Negative 4/3 is really negative 1 1/3, and it would be a closed point. And then 4/3 is really 1 1/3, and it'd be a closed point. And you always read it from the x. X is greater than negative 4/3, so we're going this way. And x is less than 4/3, so we're going this way. So there's your conjunction answer right there. Okay, all right, not too bad. Making some pretty good time, and hopefully you guys will do well on this exam that's coming up. All right, let's look at some more problems here. Now I think, let me take a look here at something. Yes. Now here's where you get to really become men of integrity. These next 7 problems are from your test that you're taking right now. These are the exact problems off of your test, so you're not allowed to watch the rest of this video until you've turned your test in. You're like, well, Mr. Jarrett, why'd you do that? Well, guys, I'm not mad or anything at all, but your test was really due Wednesday. Okay, now again, I'm not upset. I'm not criticizing. I'm just defending myself as to why I would do this. Your test was due Wednesday, okay? So this is Thursday's video, and so if you've not finished the test, please stop the video now, look at the time bar down below, see what time you're at, and then after you turn your test, and you can go ahead and turn this on and watch the rest of the video and take notes on it so you get your 5 bonus points. And by the way, don't forget, if you'll take notes on all of your videos, you will get 5 bonus points on your test as long as you turn those in. All right, let's start off with this problem right here. This is called an exponential equation, and it's called that because you have an unknown here in the exponent and an unknown here in the exponent. Now your goal is always to write both sides with the same base. Now sometimes you can't, but sometimes you can. So I've got a 3 here for this base and a 9 here for this base. So what I'm going to do is I'm going to leave a 3, and where this 9 is here, look what I put. I'm going to put 3 squared for 9 and then put my 2x here. And now I'm getting pretty close to having the same base, okay? So 2x times 2, I can multiply my exponents together. That would give me 4x. And now look at that. I've got one side with a base of 3, one side with a base of 3, so I can really just set my exponents equal. 1 minus x equals 4x. Now bring this negative x over and make it positive, and I have 1 equals 5x. And now divide both sides by 5, and I have 1/5 equals x. And there we go. That is the correct answer, okay? All right, let's go ahead and take a look at another problem here. Let's take a look at this exponential equation right here, all right? Now, your goal is always to write both sides with the same base, but in this case, there is no way we're going to be able to write both sides with the base of e. So what you do is this. Notice I have one unknown right here, and what is the base of the unknown? E. So I'm going to take the log e of both sides, okay? You can do that as long as you do it to both sides. There. Now the reason I did that, here's why. Notice over here I can use one of my shortcut log properties. Whenever the base of the log matches the base of the argument, the entire thing just equals the exponent. So this whole thing is gone, and I'm really left with x. Now over here, I have x equals log base e of 80, which is really the same thing as the natural log of 80. So x equals the natural log of 80. So I'm going to grab my calculator, type in natural log of 80, and I'm going to get 4.382026635. I'm going to round that to 4.38, okay? So there we go. Sometimes you can write both sides with the same base, and sometimes you can't. Okay? All right, let's continue on and let's try another exponential equation. Let's try this one right here. Now this one's going to be interesting. Now watch carefully, please. Notice that, this is very important you see this, guys. Okay, look. Notice I only have one exponent that has an unknown, and it's this one here. So I'm going to get the base and its unknown all by itself. So I'm going to bring this 3 over and make it a positive 3, and when I do, I'm left with this. Now, I think I can write both of these. Let's see. 4 times 4, 4 to the third power should be 64. Yes, it is. So I can write both sides with the same base. So I can leave 4 to the 2x minus 1 alone, and where the 64 is, I can write 4 to the third power, because 4 to the third power is 64. But it was so important, men, that I first isolated the base and the exponential unknown. You must get them isolated. And now my bases match, so I can really just cross them off and take the exponents and set them equal to each other. Okay, bring the 1 over and make it a positive 1, and I'm left with this. Divide both sides by 2, and x equals 2. Pretty cool, okay? All right, let's take a look now at numbers 20, 21, 22, and 23. And I believe all of these are going to be logarithmic equations, okay? Logarithmic equations. And so here we go. Let's take a look at number 20. Now, your goal when you're solving logarithmic equations is to always get the log all by itself on one side of the equation. Now, if you have logarithms on both sides of the equation, then your goal is to get one logarithm all by itself on one side and get one logarithm all by itself on the other side. Now, this problem here, we don't have to worry about that. We have one logarithm on one side, and it's isolated. Is there anything here? Forget the number 20. There we go. Is there anything to the left of it? No. Is the logarithm all by itself? Yes. And so all that we're going to do is we're going to write it exponentially. So what we would have is x equals 4 squared. You got to know how to do that, guys. You've got to be able to write logarithmic expressions exponentially, and you've got to be able to write exponential expressions logarithmically. Well, it looks like x equals 4 squared. So x equals 16. Now remember, on logarithmic equations, you must check your answers and make sure that the argument is always positive. Well, where the x is, if I put a 16, my argument is positive, so my answer is good. My answer is 16. All right, let's try one that's a little more difficult, number 21. And actually, it's not too much more difficult. We'll see here. Now, number 21, again, we have one log on one side. So we want to isolate that log. Is there anything to the left of it here? No. It's all by itself. So we're going to write it exponentially. So I should get this. 125 equals x to the third power. Now, students, please don't get confused. Please don't get confused. If you had 3 to the x power, then you're going to have to take the logarithm base 3 of 3 to the x and take the logarithm base 3 of 125. But this isn't what you have. You don't have an unknown in the exponent. See that? You don't have an unknown in the exponent. You have an unknown in the base. You have 125 equals x to the third power. And we know how to solve these. My goodness. If you have an x cubed, how do you make that become an x? You take the what root? Cubed root. But if you take the cubed root of one side, you must take the cubed root of the other side. Now the cubed root of x cubed is x, and the cubed root of 125 is 5. Students, you do not put plus minus when this number here is an odd number, and it's an odd number. So you do not put plus minus. Your answer is 5. And I know you want to come up here. Let me get a drink here real quick. I know you want to come up here and check your answer, but in this case you really can't, because look at your argument. Is there an x in your argument? No. So you know your argument's already going to be what? Positive. Your argument is a positive 125. That's not going to change. So where the x is, you would now have a 5. And that's a true statement. The logarithm base 5 of 125 does equal 3. Okay? So your answer is 5. Okay? And by the way, how do I know this answer works? We'll put a 5 here. Okay, put a 5 there. Now, if I asked you to write this expression exponentially, you would write 125 equals 5 to the third. Isn't that true? Sure it is. 5 times 5 times 5 is 125. Okay? All right, let's continue on. Number 22. All right, now here we got a logarithm on both sides, okay? But here's what's so cool about this. Now be careful here, okay? Watch carefully. We want to get one logarithm here all by itself, and we want to get this logarithm over here all by itself. Well, guys, that's not possible. Look, you've got a 3. So if I bring the 3 over here to get this logarithm by itself, then this logarithm won't be by itself. Do you see what I'm saying? And vice versa. There's nothing I can do. So in this case, what you're going to have to do is you're going to have to put both logarithms on both sides. So see this negative logarithm right here? Pick it up and bring it over here to the left side, and when you do, it's going to be a positive logarithm base 2 of x minus 2, and of course that equals 3. So I picked this up and brought it over here. Now notice I have 2 logarithms that are being added. Nothing to the left of this log, nothing to the left of this log. They both have a base of 2, and both logarithms are being added. So you've learned when 2 logarithms with the same base are being added, you can write one logarithm as long as you multiply their arguments. So now you would have x squared minus 2x, and that equals 3. Okay, so we have 2 logarithms with the same base that are being added. We can write those 2 logarithms with one log as long as I multiply their arguments. Now that we're down to one logarithm, we can write this exponentially. So if I write this exponentially, I will have x squared minus 2x equals 2 to the third power. And of course, 2 to the third power is just 8. All right. Did not mean to do that. Going a little crazy with the eraser. There we go. And it equals 8. Now you should see right away you have a quadratic equation. So I'm going to bring the 8 over and make it a negative 8 and set it equal to 0. And now we can factor this. What 2 numbers multiplied together give me a negative 8? When added together give me a negative 4? Well, I'm thinking of these 2 numbers right here. If you multiply those, you get negative 8. If you combine those, you get negative 2. So the factorization is going to be x minus 4, and this should be a 0, not a 6, x minus 4, x plus 2. Now, what solution would satisfy this parentheses? A positive 4. And what solution or what number would satisfy this parentheses? A negative 2. Now, both of those might work, they might not work. Maybe one of them will work and one of them won't work. But you need to check them in the original equation and make sure your arguments are positive. Well, 4 is fine. If you put a 4 in here for x, you have a positive 4 for your argument. If you put a 4 right here, 4 minus 2 is 2, and you have 2 for your argument. But now watch what happens when you put a negative 2 in. It only has to fail in one place, and as soon as it fails in one place, the solution cannot exist for that given number. So if I put a negative 2 right here for x, boom, right away it fails. I'm taking the log of a negative number, and your argument can never be negative. So this solution does not work. This one does. The answer is 4. All right, and now we have one more problem, and we are finally finished with the whole year when it comes to review, when it comes to video. So I might start crying here in a second. Tears of joy. Just kidding. All right, now I have 2 logs on this side, 2 logarithms on this side. So I'm thinking, you know what? I better do some super combining. I mean, look, do you have anything to the left of this log? No. Do you have anything to the left of this log? No. Are they both base 3? Yes. Are the 2 logarithms being added? Yes. We know what to do. We can write log base 3 and then multiply their arguments. And if you multiply x times x plus 1, you will get x squared plus x. Now, I have 2 logarithms over here. Is there anything to the left? No. Anything to the left? No. Are they both base 3? Yes. Are they both adding? Yes. So I'm going to write log base 3 of, multiply your arguments, 2 times x is 2x, 2 times 3 is 6. And now we're doing really well. Notice I have this logarithm isolated, nothing to the left of it. This logarithm is isolated, nothing to the left of it. So you can basically cross off your logarithms and just write x squared plus x equals 2x plus 6. Okay? And now, I mean, look, I've got a quadratic. So I know right away I want to get one side equal to 0. Bring your 2x over, make it a negative 2x. A negative 2x with a positive x combined would give you a negative x. Bring your 6 over and make it a negative 6 equals 0. What 2 numbers when multiplied together give you negative 6, when added give you a negative 1? Well, that's going to be a negative 3 and a positive 2. These 2 numbers will give you a negative 6. These 2 numbers here will give you a negative 1. So the factorization would be x minus 3, x plus 2 equals 0. Now, what number would satisfy this parentheses? 3. What number would satisfy this parentheses? Negative 2. Now let's check both of these answers and make sure they work. Okay, we don't want to have a negative argument. So here we go. Let's see. If we put a 3 in here, we're good. 3 plus 1 is 4. We really can't put a 3 here. There's no x, so that's fine. Put a 3 here. 3 plus 3 is 6. So this answer checks. Right away I can see a negative 2 does not work. If I put a negative 2 here for x, I will get a negative 2. And you cannot take the logarithm of a negative number, or for that matter, you cannot take the logarithm of 0 either. So if it's 0 or a negative number, you cannot take the logarithm of it. Okay, so there we go. The answer would be 3, and that's it for the review. Now, guys, I'm a phone call away. I'm an email away. For Caleb, I'm about 5 blocks away. Okay, so if you guys have any questions, don't hesitate to call me or email me or come see me. And it's been a good year. I'm proud of what you guys have done. However, we do need to finish well, and we have one more test to go, and then we can celebrate and be done. Okay, so I will email your test out to you Friday. It might be Friday evening, Friday afternoon. I doubt seriously if you guys are going to take it right away Friday, and so it'll be sent out to you Friday sometime. But call or email if you have any questions, and I hope this review video has been a help to you.